Problem number 1, we have the temperature outside a house during a 24-hour period given by capital F of t as 80 minus 10 cosine pi t over 12 on the time interval from 0 to 24. F is measured in degrees Fahrenheit, T is measured in hours. First thing we want to do is sketch the graph of F on the grid below. First thing I do then is to enter the function in the calculator. Next I want to set up my window according to the window that we have here. X is going to go from 0 to 24 by 6. Y is going to go from 60 to 100 by 10. And then I graph. I come up with the image here. To find values at t equals 0, 6, 12, 18, and 24, I'm going to use the value function. Second, calc value 0. And that's 70, and then 6. That's 80. And then 12, and that's 90, 18, that's 80, and 24, that's 70. And I'm just going to draw a bell-shaped curve through those points, something like that, and part A is done. Second, find the average temperature to the nearest degree Fahrenheit between 6 and 14. We say that the average temperature, average value of a function, is the integral divided by the interval. And remember, for calculator problems we have to set up the expression mathematically, not how we put it into the calculator, but mathematically, and then we use the calculator to find the answer, and we only need those two parts. So I'm going to take the integral, second, calc 7 from 6 to 14. Now the result of a definite integral, or a definite integration, is stored in the computer. All I want to do now is divide that by 8. So from this screen, if I hit divide by 8, it gives me the result of 87.162. And that's my final answer there. For part C, an air conditioner cooled the house whenever the outside temperature was at or above 78 degrees Fahrenheit. For what values of T was the air conditioner cooling the house? What I'm going to do here is set up another function where y is equal to 78, graph them. If I want to clear out the integration stuff, I'm going to hit second, draw, clear draw, and now I have the points of intersection clearly displayed there. Alright, so to find the points of intersection, second, calc, intersect. Mess that up. Back to graph. Second, calc, intersect. First curve, I say there. Second curve is there. Guess it's going to be close to 6, so I'll type in a 6, and it will give me 5.231. I'm going to store that by quitting there, clearing out, and saying store. It takes the answer, which is that x value, store it in A, and I'm going to go back again and find the second one. Second, calc, intersect. First curve, I'm going to move away from the intersection so I can see clearly. Second curve, first curve, second curve. My guess is going to be close to 18 this time, and it gives it to me there, and I am going to store that again. Second, quit, and store, in this time in B. And so now my the A and B values are there. I'm going to record them. I say that the air conditioner cools the house for T greater than or equal to A, less than or equal to B, where A is equal to 5.231 and B is equal to 18.769. I'm going to write them as A and B because then I can use A and B in my following calculations and not have to write those numbers all over again. So I'll pick up with letter D in the next video.